Now there are a few important terms that you need to know with respect to the circuit breaker. The first one is the restriking voltage. This is the voltage that appears across the contacts when the current reaches 0, at the instant of 0 current. Okay, so you note this down. The resultant transient voltage, transient because it is not going to sustain, it is going to die out after a while. So the resultant transient voltage which appears across the circuit breaker contacts at the instant of 0 current. This is called as the restriking voltage. So the expression for restriking voltage, this is going to be V is equal to some peak voltage into 1 minus cos t by root LC. So you can see this is actually a sustaining voltage, sustained oscillations, right? But in reality there is going to be resistance and it is going to be a transient value. That means it is going to die out over time. So this expression is for a lossless system. What is the frequency of oscillation here? It is 1 by root LC, because cos omega t usually we write, right? So omega is 1 by root LC. The next term is the recovery voltage. This is the RMS voltage that appears across the circuit breaker contacts after the final arc extinction. Next term is the rate of rise of restriking voltage. This is abbreviated as RRRV. So this is nothing but the differentiation of the recovery voltage. Okay, RRRV is equal to dV by dt. So this is d by dt of Vm into 1 minus cos t by root LC. Okay, so the final expression you are going to get Vm by root LC sin t by root LC. This parameter will decide whether the arc will be extinguished, whether the arc can be extinguished or it will be sustaining. Sustaining means maintaining, right? So the rate of rise of restriking voltage, it should be lesser or it should be slower than the rate of the development of dielectric between the contacts. So you can write that point here. If RRRV is faster than rate of development of dielectric between the contacts, then arc will sustain. So the next term that we have is current chopping. So what is this current chopping? We interrupt the current when it reaches a natural zero, right? The alternating current will reach a natural zero. At that point we interrupt the current, okay? But if the current is interrupted before the natural zero is obtained, that is called as current chopping, okay? So the interruption of current before it reaches natural zero is called as current chopping. Now what is the issue with this current chopping? Why are we concerned with it? The current interruption by the circuit breaker, we can consider this circuit. Here the circuit breaker is present, so we will call this as CB. We take it like a switch, and here there is a capacitor. So a capacitance will be present across the circuit breaker. So we are dealing with the lossless circuit here. That means there is no resistance. Now what is going to happen when a natural zero is achieved? Then there will be no magnetic energy in the inductor, right? The instantaneous magnetic energy. But if the current is having a non-zero value, that means there is some magnetic energy at that instant of time, right? And that magnetic energy, it cannot become zero instantaneously, right? The current through inductor cannot become zero instantaneously. So what is going to happen? This magnetic energy is going to get converted into electrostatic energy, which will then be stored across the capacitor. So a voltage will be developed across the capacitor, right? Because what is the energy stored in a capacitor? Half CV square. Okay. So voltage will be developed. So first you write down when current is interrupted at a non-zero value, the magnetic energy cannot instantaneously become zero. So this electromagnetic energy, it will be converted to electrostatic energy, meaning that now voltage will develop across the capacitor. And here also you have to remember that the voltage across capacitor also cannot change instantaneously, right? So it will slowly develop. So if the non-zero current had a value of say I, then the voltage that will be developed across the capacitor will be I into root over L by C, the voltage that will be developed. This expression you can get by equating the electromagnetic and the electrostatic energy in the capacitor, right? This is half Li square electromagnetic energy and electrostatic energy is half CV square. But what happens is, before the voltage reaches this value, the circuit breaker will again strike. It will again chop the current, because the deionization effect in the circuit breaker, if you are taking an air blast circuit breaker, then air will be blasted into between the contacts. So the blasted air, it will ensure that there is deionization happening, and that is going to chop the current again before the voltage is going to reach this particular value. This value is very high, it will be very high, and this might create a high voltage stress. A high voltage stress means there is ionization, right? So you can write the voltage that is developed across capacitor creates a high voltage stress. But before the voltage reaches that high values, only restriking of the arc will occur. So, but before voltage reaches such high values, restriking of arc will occur. But then again, deionization is being continuously offered by the circuit breaker. But since CB continuously tries to deionize, the current will be chopped again. Okay, and like this, a series of current chopping will occur till it finally becomes zero. A series of current chopping might occur before current finally becomes zero. Next is resistance switching. So we saw that very high voltages might develop across the circuit breaker. So a resistance will be connected across the circuit breaker so that the voltage is not increased to such high values. A part of the non-zero current will flow through the resistance. Okay, so there is a current diversion taking place. So as we know, voltage across the circuit breaker contacts can become very high due to current chopping. To reduce this, a resistance is connected across the contacts so that a part of the arc current is diverted into the resistor. Usually the value of this resistance, it is going to be 0.5 into root over L by C.